The show that reveals how extraordinary items in our world are designed, constructed and produced. See the engineering, the technology and big ideas that make the world go round. Find out how it works. Coming up, how a factory full of sewing machines produces 45,000 pairs of socks every day. Handcrafted to perfection, the making of a mountain bike. And just what is freeze drying? Discover the production process that lets you make a cup of coffee in an instant. But first, you don't just need the best grapes to make a great bottle of wine, you also need a fine cork. You might not have realized it, but cork really does grow on trees, and most of those trees are here in Portugal. These men hack the bark from the cork oak trees with hatchets. This is what will be used to make the corks. It looks like a rough process, but these guys are specialist debarkers and are not harming the trees. It'll take 9 years for the bark to grow thick enough to be cut again, but with the care they're taking removing it, they'll be able to harvest it many times over the 150-year life of each tree. There are around 2 million trees in this forest alone. And as they provide 20 kilos of bark each, huge amounts are collected and brought back to yards like this one. There are 15,000 tons of cork slabs here. First of all, they boil the bark to make it softer and more flexible. It's moved around the factory on large pallets. This one's loaded with over 1,300 kilos. After it's been washed, the bark goes back out into the yard for around half a year, so it can absorb moisture from the air. About 6 months later, it's brought back indoors, where it's cut into strips by a circular saw. The strips go straight to these workers, who punch the cork shapes out. The offcuts aren't going to be wasted. We'll find out what happens to them a bit later on. As the corks file along this belt, an automated system checks and sorts them according to how porous they are. Then it's time for a human touch. These women sort them into batches of different qualities. They have to get it right because the best corks can go for 50p each, but the lesser ones cost just a few pence. In the lab, they have to check how the different corks react when they come into contact with liquid. Sometimes mildew builds up on a cork, turning the wine bad. That's when a bottle is referred to as being corked. By testing samples from the batches, they can tell if that's likely and stop it from happening as much as possible. This is where those offcuts have ended up. They're crushed into small pieces and then taken off to a machine where they'll be mixed with adhesive. The mixture is then heated and pressed to form these 2-metre corks. The humble offcuts are actually going to be used for some of the finest wine of all, champagne. After the 2-metre corks are cut down to size, 2 discs are glued on top. The champagne corks won't get their recognisable shape until they're actually put into the bottle. At the posher end of the line, the best corks are labelled and sorted into bags, ready to make their way to vineyards, into a bottle and onto a corkscrew at a dinner party near you. Bikes have come a long way since 1816. Back then, a German baron made the first one that could steer, although it still didn't have any pedals. But as the design improved, its popularity soared. In the UK today, we buy over 2 million bikes every year, and over half of them are mountain bikes. A state-of-the-art mountain bike starts life as a pile of aluminium tubes. This manufacturer makes bikes to order, so each frame can be customized to the measurements of its future owner. First, the tubes are cut down to size with a circular saw. The ends are slightly flattened. This makes them stronger and more durable. Then it's clamped in a vise where it's drilled with a circular bit the same size as the tube to which it'll be connected. It's accurate to 1/10 of a millimetre, which ensures that the frame will fit together perfectly. Once all the tubes have been cut and drilled, the frame is assembled on a jig bench, held into shape by brackets. Then they can weld it together. A steel welding rod is heated and becomes molten at the point of contact. It forms an incredibly strong bond that will help the bike endure the huge stresses that'll be exerted on it. One by one, the tubes are joined to form a solid frame. It's incredibly sturdy, despite the fact that it only weighs a touch over 1¼ kilos, just a bit heavier than a bag of sugar. Back at the jig bench, they check it still fits the template, as sometimes the welding can cause distortion. Each tube has to fit to the millimetre. This frame's slightly out, but it can be forced into shape with a bit of gentle persuasion. Once it's perfectly aligned, it's baked in an industrial oven for 24 hours at 180 degrees Celsius. This causes the steel to harden and the tubes become virtually inseparable. Next, the frame's surface is treated in this airtight blue unit. The process works in much the same way as sandblasting. A gun sprays tiny particles of glass onto the frame and removes any residues which are lurking on the surface. The before and after effect clearly shows the benefit of the process. Once it's been cleaned up, the frame's hung on a hook that connects it to an electric current. The spray gun charges the paint particles to the opposite polarity, and this causes the frame to attract the paint like a magnet attracts iron filings. They mask off some areas with tape, and then they can spray on the second coat of paint. Any excess is carefully blasted away with compressed air. The frame will go back into the oven for a further 20 minutes, and this will fix the varnish to ensure a lasting shine. After it's been baked, they add some finishing touches, and it's ready to be attached to the rest of the bike. The rear forks are first. They've got an inbuilt suspension system with a hinged mechanism. A shock absorber is added, which will make for a smoother ride and protect the biker from injury on rough terrains. The front forks and handlebars are fitted, and the wheels come next. They've got disc brakes, which are more reliable than caliper brakes that wear easily and can fail in wet weather. A derailleur is fitted at the back. It's a mechanism that moves the chain onto different cogs to change gears. The fitter threads on a cable that connects to the derailleur and checks it's all working smoothly. Finally, the pedals are added. They're designed like a ski binding so that the rider can snap his shoes in and out with the minimum of fuss. From start to finish, the mountain bikes have been assembled by hand, just like the first bikes nearly 200 years ago. But these ones have been crafted from lightweight aluminium tubing, fitted with hinged forks, and they've got pedals. Coming up after the break, we put our best foot forward to find out how they mass-produce socks. And how coffee beans from South America are turned into granules in a jar. Across the world, we drink about 2.25 billion cups of coffee every day. We've been drinking it fresh for over half a millennium, but instant coffee is the new kid on the block, as it wasn't invented until 1901. 70 tons of fresh coffee beans arrive from South America at this instant coffee factory every day. Up to 560 tons are stored in this huge silo. The raw beans are filtered down into large ovens, where they're roasted at 200 degrees. This is where they get their characteristic colouring. They're stirred constantly to make sure they're evenly roasted without burning. From there, the beans fall down into an industrial mill, where they're ground into a coarse powder. This plummets down into one of 8 huge coffee machines where the flavour is forced out by hot steam and pressure. They brew up enough fresh coffee to wake up an army of office workers. 18,000 litres in just an hour. The coffee is heated until it's condensed into an extract, and that's spread onto a conveyor belt which will take it away to the next station, the freezing hall. The workers have to wrap up in thermal clothes to protect themselves from the Arctic temperatures, minus 50 degrees Celsius. To lock in the coffee's aromas, the extract must be frozen solid, at least as cold as minus 40 degrees. At the end of a 30-metre-long conveyor, it's broken up into granules. In the harsh environments, they use cameras to check everything's running smoothly. If a worker spent too long in the deep freeze, he'd be going home with frostbite. The deep frozen granules still contain water which they need to get rid of. Stacked up on trays, they're driven through a low-pressure tube for 5 hours. The challenge is to remove the remaining water without the coffee becoming liquid again, as this would release the aromas. Here's how it works. The granules are heated at 60 degrees Celsius in a strong vacuum. Under pressure, the frozen water vaporizes and turns straight into steam. This is a process called sublimation. As the granules come out of the vacuum, they have been freeze-dried. The aromas have been locked in and they'll stay solid at room temperature. The trays are flipped over and the granules fall into huge storage sacks ready to be packaged. The jars whiz along a conveyor belt and are filled in less than a second. They get an airtight seal and move towards the factory door, picking up a label on the way. 420 tons of instant coffee leave this factory every week, but it will be made up into just a small proportion of those 2.25 billion cups of coffee we drink each day. In 2005, over 600 million pairs of socks were sold in the UK. As well as being comfortable, best sellers also have to be fashionable. So before a sock's first stitch, a designer works out a colour scheme and pattern. Flashy socks aren't a modern-day invention. Barbarians were steaming into battle wearing brightly coloured socks well over 1,000 years ago. Once the designer's happy with the pattern, she can pick out the exact colours. This can take some time. There are more than 500 different shades to choose from in this studio alone. That done, she can model her design on a computer. It does the maths for her, calculating the width and number of rings, sequence of colours, and even the number of loops. The threads are collected from this warehouse. They've got 170 different types, made from wool, cotton, cashmere, silk, mixed threads, and chemical fibres. They use 1,500 tons of it every year, so a bit of variety does go a long way. Over in the sewing hall, 400 knitting machines are constantly churning out socks. They knit a whopping 45,000 pairs a day. One of the workers mounts the threads onto a machine and then inserts a data card which contains the design. The knitting machine gets through 27,000 loops in just a minute. Even the largest of sewing circles would struggle to match that pace. It's just a blur of colour to the naked eye. But in slow motion you can see some of the 160 needles that are knitting the fabric into tubes. After about 5 minutes, they're long enough, 66 centimetres to be precise. They're sucked through a cylinder towards the next station. They've been stitched inside out and need to be reversed. A vacuum helps, but unfortunately the repetitive task of mounting them has to be done by hand. The socks are almost finished, but they're not ready to hit the high street yet. There are large holes where the toes should be. Each loop of each sock has to be carefully mounted onto a row of needles. It's a job that requires concentration, a steady hand, and the patience of a saint. A machine cuts off the spare fabric and sews the loops together. Once the toes are closed, the socks are steam pressed at 130 degrees Celsius. 7 seconds is all it takes. Any longer and they could get singed. Crease-free, they'll now be fresh and comfortable to wear. That's more than can be said for the earliest known socks. The Greeks made them nearly 3,000 years ago out of matted animal hair. Before they head out of the factory door, a quality controller gives them a once-over. Finally, they're paired up and sewn together to make sure they stay in pairs. For now.